In this video, we're going to go through some of the multiple choice questions from the January 2023 Geometry Regents exam. All right, let's get started with number 1. In the diagram below, a line reflection followed by a rotation maps triangle ABC onto triangle DEF, and we want to know which statement is always true. So for a question like this, reflections and rotations are rigid motions, which means that distance and angle measure is preserved. But what might be helpful for us answering this question is to redraw one of the triangles so that the pieces match up. So what I mean by that is I'm going to put D on top, E on the left, F on the right. That way I can see that A and D correspond to one another. I can see that B and E correspond to one another, and C and F. And I know those are supposed to correspond because that's how the problem lists the two triangles. Since A is listed first and D is listed first in their respective triangles, those two should be corresponding points. So now let's take a look at our answer choices. Number 1, BC and EF. Those are two corresponding line segments, so that looks like it's going to be true, but let's still check the other options. 2, AC and DE, those do not correspond, so that's incorrect. Angles A and F do not correspond, and angles B and D do not correspond. So the answer to number 1 is choice 1. Number 2, a circle is continuously rotated about its diameter. Which three-dimensional object will be formed? So let's take a look at what a circle and its diameter looks like. And if we're rotating it about the diameter, it's basically spinning around here in order to form a three-dimensional shape. And when I continue to do that, I'm going to get choice 3, a sphere. Just a note, choice 2 is not ever a possible answer to these questions. A prism does not have any circular bases or faces to it, so it is not possible to create a prism through some sort of rotation. Okay. All right, number 3, in the diagram below of triangle CER, LA and CR are parallel to one another. That tells us that LA is basically something called a side splitter. Let's label the diagram. It says CL is 3.5, LE is 7.5, EA is 9.5, and we're looking for the length of AR, so I'm going to put X there. So we could separate the triangles, but I actually don't have to here because since I know that LA and CR are parallel to one another, LA is a side splitter, and that means that it splits the sides proportionally. So I can make a proportion 7.5 over 3.5 equals 9.5 over x. When we cross multiply here, 7.5 times x is 7.5x. And then I have 9.5 multiplied by 3.5 gives me 33.25. And let's divide both sides by 7.5. And I get 4.433333 over on my calculator on the right, and that gives me choice 2. Number 4, right triangle ABC is shown below. Which trigonometric equation is always true for triangle ABC? The Regents loves asking questions like this where it's asking about cofunctions. So sine and cosine are cofunctions. Even if you think about the word sine, cosine, it has the prefix co in front of one of them. And that basically means that those two functions work together. So the key is looking in the picture for the two acute angles, the ones that are not the right angle. So that's C and A. And we know that the sine of one of them is equal to the cosine of the other. And that is exactly what choice 1 is telling us. Okay, the sine of A is equal to the cosine of C. Let's say that you were unsure of this and you have trouble memorizing that rule that the sine of an angle is equal to the cosine of its complement. Make up some numbers here, anything that you want. Now let's try choice 1. The sine of A, opposite over hypotenuse, right, using SOHCAHTOA, would give me 3 over 5. Cosine of C, that's adjacent over hypotenuse using SOHCAHTOA, gives me 3 over 5, and I get both to work. Okay, so you could always make up numbers if you have trouble memorizing that rule. All right, number 5, in the diagram of triangle ABC below, AE bisects angle BAC. I'm going to just mark that off up here, that these two angles are congruent. And altitude BD is drawn. And altitude is a line segment that forms right angles, so I'm going to put the little right angle markings in there. If C is 50, and angle ABC, so this whole big angle here, is 60, we want to find the measure of angle FEB. So what I'm going to do in my picture is I'm just going to put a little question mark next to the angle that we're trying to find as a reminder. So sometimes people get discouraged on these problems because there's no immediate way to figure out that angle. Consider these problems like a puzzle where you have to fill in anything that you possibly can. So here's how I'm going to start. I'm going to look at the big triangle. There's so much going on in this picture that we might neglect that big triangle. And I'm going to just take a look at it off to the side here to make it easier for you to see. We know that this is 60. We know that this is 50. And we know that a triangle has 180 degrees. So that tells me that this angle at the top must be 70. Well, we were also given the information in the problem that angle A, or angle BAC in this case, was being bisected. So I know that this is 35 and 35. Okay. So again, use the big triangle and use the fact that we know that the interior sum of the angles in any triangle is 180 degrees. Now, I'm going to go and fill in anything in my picture that I can. Again, I'm not worried about that FEB. We don't know it yet. Let's just find anything. So I'm just going to erase that highlighting here. I can see, and I will highlight and unhighlight a couple times. I can see that this is another triangle here, so I can find that missing angle. 35 plus 90, right, because we have the right angle in there, is 125. Subtract that from 180, and I know that this is 55. I also see a pair of vertical angles here, so I'm going to fill in 55 here as well. And then I have these supplementary angles here. Those are two angles on a straight line. They form a linear pair, and linear pairs are supplementary. So I know that this is going to be 125, and this is going to be 125. And again, I'm just filling in anything I possibly can. All right, next, let's take a look here. And there's different ways to go about this problem, but here's what I see next. I have a four-sided shape here, which is called a quadrilateral. Any quadrilateral has an interior angle sum of 360 degrees. So I already have 125 degrees. I already have an angle of 90 degrees. And I already have an angle of 50 degrees. And you can see me typing that in on my calculator on the right. So that gives me a total of 265 degrees. Well, if that shape is supposed to have 360 degrees, let's subtract that. And I know that this missing angle in the quadrilateral is 95. Here's another linear pair. Based on that, those angles should add up to 180, and I get 85 degrees as that answer. Now, I just want to give everyone a hint. If that problem seemed difficult to you, and it seemed like way too many facts that you have to know, I could have probably guessed the answer was 4 just by looking at the picture. If you look at the angle they wanted us to find, it looks slightly smaller than a right angle. And there's only one answer choice in this problem that is slightly smaller than a right angle, and that's choice 4. So there might be this warning that diagrams are not necessarily drawn to scale, but very often they are, and we're going to use that to help us here. All right, moving on to number 6. A jewelry company makes copper heart pendants. Each heart uses 0.75 cubic inches of copper, and there is 0.323 pounds of copper per cubic inch. If copper costs $3.68 per pound, what is the total cost for 24 copper hearts? That is an overwhelming question with all of that information. So here's how I start. I just write down whatever the first fact they gave me was, which is each heart uses 0.75 inches cubed of copper, and I like to put that over 1. I know that my end goal here is to figure out dollars. Like I have to get rid of every other unit. So let's move on to the next fact. 0.323 pounds of copper per cubic inch. So I'm going to multiply by that next fact, 0.323 pounds of copper per 1 cubic inch. This is the way that I would need to multiply these because I need these cubic inches to cancel out and go away because I don't want that unit anymore. Okay, next fact says copper costs $3.68 per pound. So I'm going to fill in 368. My unit there is, of course, dollars. And that's per pound, so 1 pound. Now my unit of pounds has disappeared. Anytime there's a unit on top and bottom, they disappear, or we can say cancel, because basically those are equal to 1, right? Think about, for instance, if you have 5 divided by 5, we cancel that and say that's 1. That's basically what we're doing here. And so this would give us the cost for 1 copper heart, but we know that we need 24 of them, so I'm going to multiply by 24. So let's just go to our calculator and multiply all of these values. So 0.75 times 0.323 times 3.68 and times 24. And that gives us a total of 21.39552. And when we are working with money, notice there's no rounding directions in this question. When you're working with money, it's always 2 decimal places. So that's why choice 2 is going to be our answer, $21.40. Okay, number 7, in right triangle LMN shown below, angle M is 90 degrees, MN is 12, LM is 16. The ratio of cosine of N. So let's look at let's look at angle N in the picture. This is the opposite side. This is the adjacent side. And this is the hypotenuse. So cosine using SOHCAHTOA is adjacent over hypotenuse. So I know that cosine of N is 12 over whatever the hypotenuse is. So I can eliminate already choices 2 and 4 because I can tell the numerator is incorrect. I could also probably guess at this point that it's choice 1 because I can see that 16 represents the opposite side and not the hypotenuse. But let's verify that the hypotenuse is in fact 20 in this question. This is a right triangle. To find the missing side of a right triangle, we can use Pythagorean theorem. This will give us 400 equals c squared. And sure enough, our hypotenuse is 20. So cosine being adjacent over hypotenuse, that's 12 over 20 or 1. And again, just as a reminder, how do I know that that's adjacent over hypotenuse? It's just by using this acronym SOHCAHTOA. Since I'm looking for cosine, it's the one with the C, so the ca part, and A for adjacent, H for hypotenuse. Number 8, in triangle ABC below, DE is drawn such that D and E are on AB and AC respectively. If DE is parallel to BC, which equation will always be true? Now, you remember we saw the problem earlier in this video about the side splitter, and we were working with the sides. On a question like this, where you do not have any numbers, I would definitely recommend drawing the triangles separately. So I'm going to draw triangle ABC. I'm just going to shift it off to the side. And I'm going to draw triangle ADE. And let's clean that up. And since these two triangles, or since these two lines, DE and BC, are parallel, that is going to indicate that the triangles are similar because you will get these congruent corresponding angles. Angle A is in both of them, so according to the reflexive property, they are congruent. Angle A is congruent to itself. So the triangles are similar. Now let's see if we could figure out which proportion works. So choice 1, AD to DE. Okay, so notice here to here is equal to DB DB is not even a segment on my separated triangles, by the way, so I don't think that's the answer. And BC. That's not going to work. GB is not even there. We're going to get rid of that. All right, let's look at choice 2. AD to DE, AB to BC. That works. Notice how the two numerators, AD and AB, are corresponding pieces. The two denominators are corresponding pieces. So choice 2 is going to be our answer on this one. If I go through 3 and 4, you will find that it does not have corresponding pieces lined up in the proportion. Number 9, which polygon does not have congruent diagonals? This can be hard to memorize. You could always draw pictures of these shapes and try and reason it that way. So for instance, like for choice 1, if I were to draw a square here to the best of my ability, the two diagonals, they look congruent to one another. And the same thing if I were to draw a rectangle. It does look like the diagonals are congruent. So I don't think it's choice 1 or 2. 3 or 4, a rhombus. Looks something like that. This diagonal does look a little shorter than the other one, so I'm thinking that could be our answer. And if I draw an isosceles trapezoid, we'll have something that looks like this. And sure enough, those two diagonals look congruent to one another. So choice 3, rhombus, is our correct answer. Number 10, if the circumference of a standard lacrosse ball is 19.9 centimeters, what is the volume of this ball to the nearest cubic centimeter? So anytime you see a question that has volume, turn to your reference sheet and you'll have your volume formulas there. So I know that a lacrosse ball is a sphere. And if I look at my reference sheet, that formula is 4/3 pi r cubed. The problem here is that it doesn't tell me anywhere what the radius is, but instead it gives me this fact that the circumference is 19.9. So we have to do a little extra work on this problem. So if you look at your reference sheet, you will also see a formula for circumference. You'll actually see 2, but I'm going to pick the one that has the radius in it. And you'll see C equals 2 pi r. Let's solve this for the radius. And let's see what that comes out to. So I'm going to, anytime you're typing in fractions, I like to stack my fraction like that. So to get that, I'll start that over again just so you can see. I'm hitting the alpha button, then y equals, and I'm picking choice 1. This eliminates the need for parentheses, and I could just type it in exactly the way that it looks on my paper. And I get that my radius is 3.16718336775. This is not my answer to the question, and I'm not going to round this. I'm still working on this question, so any problem, don't round to the final answer. Now I know what the radius is, so I'm going to plug that whole number, I'm going to plug that whole thing in here for r. Okay, so now let's use our calculator to calculate that. So again, stack my fraction, 4/3 times pi. And I'm going to copy and paste that number in. You could retype it in too. To copy and paste, by the way, I just used my up arrows to highlight it and then hit enter. And that should be a 3 here. Always keep that in mind, right? It's easy to accidentally type in a 2. The volume of a sphere formula is actually cubed. And let's hit enter and see what we get. So we have 133 point and a whole bunch of decimals to the nearest cubic centimeter. That means the nearest whole number, choice 2. All right, number 11, which polygon always has a minimum rotation of 180 degrees about its center to carry it onto itself? So one thing I notice in this question is that choices 2 and 4 are regular polygons. Okay, so I'll jot that down in here. 1 and 2 are not regular or irregular, whatever you want to call them. A regular polygon is a shape where all of the sides and angles are equal to one another. So when I'm finding the minimum rotation for a regular polygon, the formula is 360 divided by the number of sides. So if I do that for choice 2, 360 divided by 4 is 90. That's not our answer. We're looking for 180. In choice 4, if I do 360 divided by 5, I get 72. Not my answer because I also need 180. All right, so now let's take a look at choices 1 and 3. For the shapes that are not regular, we don't have a clear-cut formula we could plug in, though I will give you a tip that you could use. But what I like to do is just think about it. If you are writing on a piece of paper right now, I'm going to guess that it is a rectangular piece of paper. And if you turn your paper 180 degrees, you have a rectangle that looks just like it did before, right? That basically means it mapped or carried onto itself. If I take a trapezoid, or an isosceles trapezoid in this case, and I'll even show you here. Let's see if I can make that nice and neat. Oh, let's try one more time. If not, I'll draw my own. My iPad does not like my trapezoids, so I will draw one here. There we go. Here's an isosceles trapezoid, or close to it. If I take this trapezoid and I try and rotate it 180 degrees, notice how it does not look the same. It's facing a different way. So that's going to make this incorrect. It's not 180 degree rotation, and my answer is choice 1. Here's another tip you could use to help you. Instead of the 360 divided by number of sides, one rule you could use is 360 divided by the number of lines of symmetry. So a rectangle has 2 lines of symmetry. So if I do 360 divided by 2, I'll get 180. So that's another way you could answer this question. All right, number 12, circle O is drawn below with secant BCD. The length of tangent AD is 24. If the ratio of DC to CB is 4 to 5, what is the length of CB? Anytime I see these ratio questions, put X's in. So I'm not going to label DC as 4. I'm going to label it as 4X. I'm not going to label CB as 5. I'm going to label it as 5X. And then I can go and do my problem after that, okay? So the rule for when you have a secant and a tangent and you're looking for length is the outside times the whole equals the tangent squared. So the outside means the part of the secant that is outside the circle, so that's 4x. The whole means what's the length of the whole entire secant? All of this, we'll add that up and we get 9x. And the tangent is 24 squared. All right, let's simplify this. 4 times 9 is 36. X times x is x squared. 24 squared is 576. Let's divide both sides by 36. I have x squared is 16 and x is 4. But be very careful. Do not fall into the trap of just circling choice 4 right now. Pay attention to what are we actually asked for. And in this case, we're asked for the length of CB. So look at CB in your picture. We labeled that with 5x. So plug 4 in. 5 times 4 is going to be 20, or choice 2. Okay. You can head to the next video in this playlist to watch questions 13 through 24.